Hey guys, today we are working on a 2004 Jeep Grand Cherokee and it is a no start. All I know is the vehicle doesn't start. I don't know if it's a no crank or if it is a crank, no start, no spark, no fuel. Filming live, I just connected the scan tool, never identified the vehicle, I never even turned the key on yet. I think one of the things that you guys like about what I'm doing is when we do it this way. Let me walk you through the process, and speed and accuracy is always the key. And today for me, it is speed. I want to get out of here. I don't really feel like doing this. It's been a long day already, so let's see what we can find on this. First thing I'll do is take you inside and we'll crank it, see if we have an RPM signal, see if it cranks, and I'll get you a shot of some scan data. Not doing any scan tool tests just yet. You guys just watch this guy right here. And we'll turn the key on, do a bulb check too for the check engine light. There's my check engine light. And Chryslers will typically turn off after a few. Not really important whether it does or doesn't, I don't think. I don't know if you guys can see that light. You probably can't anyways. It looks like steering wheel's in the way. It's actually flashing at me right now, and I didn't even initiate a flash sequence. Anyway, I'm not counting flashes. I have a scan tool. Watch the tack right here. Of course, my battery's weak from someone cranking it before me. I brought the jump pack with me. I did not see the tack move, just as a guide that is suggesting an input problem, but we don't want to totally rely on that test. It is a useful test, but not 100% accurate. Okay, first thing I'm going to do is go to codes. Hey, no crank reference signal. That's cool. P0320. This should be relatively easy. One trip. Just reading my other code menus. So the only code in memory is my crank. Let's look at some data PIDs now. What we're going to look at is crank count and cam count. These two guys right here. Not sure with the glare if it's going to help to graph it. And then RPM is right underneath that. I'm going to crank it. You guys can watch. And nothing. No cam, no crank, and no RPM. Now the thing about these data parameters, the cam signal sometimes will not update unless there is a crank signal available. So I'm not going to be too worried about the cam. Something else that is on my mind is these Chryslers like to set cam codes whenever there's a faulty crank sensor, or set crank codes with a faulty cam sensor. I've seen both, so we need to be careful with that. Going under the hood now, and I'm going to do some direct measurements on the crank sensor itself. Alright guys, this is where it helps to know systems, and I'm familiar with this 4-liter Jeep, and that helps to know where connectors and stuff are. The crank sensor is driven off of the bell housing, and the sensor wiring comes across over to here. There's a 3-wire sensor down right by the oil dipstick or transmission dipstick, and then the cam sensor is driven right here on the side of the block. So we'll do our checks right there. Probably have to do both of them. We'll see. As far as my hookups, just using my Varus, using my yellow lead channel 1, just going right to my crank sensor. Black lead is going to known good ground, which in this case is going to be battery ground. Not sure how well you're going to see this. There's again a 3-pin connector. I'm looking at wire colors too. Nice thing about working on Chryslers for a long time is you learn wire colors too. I have an orange and something, a black and a light blue, and a gray black. The orange and whatever trace that is my reference. The black light blue is sensor ground, and the gray with a tracer, gray black I think, is my crank sensor signal wire. Can I get down there and do this test? You guys are not going to see the connection, but I'll do the best I can to get you a shot of it. Could be worse. T-pin did not feel like it went in there. It's not really a T-pin, it's like an insulated back probing pin. Let me get you onto the scan tool. I'm going right to my lab scope. I don't need any guided help. I know this system very well. The signals on these are 5-volt pull down designs. Turn channel 2 off for now. Channel 1 will set to 10 volt will be fine. Actually, we can use 5. Or no, we'll use 10. And I'll let you guys see the min-max numbers. I have the key on right now, I think. Let me make sure my key's on. Yep. Key is on. A little blip in that signal there. I need to double check my pin connection because I should have 5 volts on this wire right now. Now, depending on where the window is for the reluctor of the flywheel, that will make that determination. So in other words, sometimes it's normal to have 0 volts with the key on, and sometimes it's normal to have 5, depending on where that Hall effect window stopped. I don't believe I'm making connection here. Very difficult to reach. Okay, I believe that I am now. 2 things happen. You can see, 1, see the line is smooth, and 2, I'm reading a flat line 0.6 of a volt. And I'm gonna crank that. We got a long buffer here. I'm set on a 5-second time base, which is way too much for detail, but I want to see repetition right now. Cranking it. Yeah, that really didn't change much at all, did it? Let's go back and look. Zoom. And this is the area in here, I believe, where I was cranking it. Yeah. Had a little bit of change there. It dropped actually, didn't it? Go back to that. Right in there, I believe, is where I was cranking it. No square wave. All right, so before we condemn the sensor, a few things we need to understand. His power, ground, of course, and then the signal. And the signal circuit's critical here. This is section 2 material in my book, which I have described as switch inputs. And this is a pull down design Hall effect circuit, which is critical in knowing whether or not we have opens and shorts in the signal wire. All I need to do on a pull down design, let me make sure my key's on, it is. All I need to do is to disconnect the sensor at this point while I'm monitoring the signal wire still. I'm reading 0.6. If I disconnect this sensor and that reads 5 volts, we're done. That Hall effect is shorted. Now, we'll still check the reference and ground for you guys, but if you know this sensor, if I have a bad ground, I'm going to have 5 all the time. And if I have no reference or no feed voltage, I am also going to have 5 all the time on this design. There's 2 separate 5s. One's a feed The other is the signal. So now there's other variables too with this, such as a shorted internal 5-volt circuit, which would point externally. And now I'm talking about reference circuits and a lot of detail and theory involved. I don't want to do that right now. That would be section 9 material that I have in my book, 5-volt reference circuit. You guys have been following me. Look, you don't need to buy the book. I'm just trying to explain my thought process here, and there is so much involved with the reference circuit that I really just can't do that right now. So I'm referring you to that section, or look or watch my other videos where I have it segmented in my playlist for the reference circuit. Do yourself a favor and watch them. Unplugging the sensor. Hopefully while maintaining my connection. It's going to be difficult. Sensor's unplugged. That's not, okay. That was very delayed. Why was that so delayed? Was it my pin moved most likely? Let me just make sure. I'm wiggling that. Yeah, that's definitely what it was. All those drops in that signal you guys are looking at is a loose back probing pin. Okay, we got a good signal. That means the signal wire is good from the computer all the way down. Last 2 checks would be the reference and ground, which will be done plugged in. So I did this maybe a little bit out of order. I got to plug it back in now and check the other 2 because we want to do loaded circuit type tests. But before I do that, just to save a step here, what I can do now is known as a bypass test. Go back to my scanner and my crank count, which watch that guy right there. I have the key on, and remember my yellow lead is connected to my signal wire, right? Take a incandescent test light. In this case, you could actually use a jumper wire. And what we're going to do is a Hall effect bypass test with this fancy tool right here. I'm going to disconnect the yellow lead from the top of the Varus, and right now what I have is I have my 5-volt signal right here on the end of this. Take your test light on and off, and what we can do is we can create a RPM signal. I just heard the injectors click. See the scan tool read that number. So I'm creating a false RPM signal. My light is not lighting, important to note. I'm using an incandescent light, and I am pulling it to ground, simulating what the sensor would actually do. That is a really cool test. No question about it, that crank sensor is faulty. And if I would do that at the same time I cranked it, I would get a cam count. The only problem with that would be I would be triggering it at the wrong time, and I could cause a backfire or something like that. Thinking of a case study I did recently, I'll have to put a link in here for that, where I show this exact test on a Jeep that had a faulty cam sensor, I think. It's a cam or crank, I don't remember. I'd like to show it again, but I kind of would need Pete to come up here and crank this for me. I think maybe I'll have him do that. Okay, before we do that last check, let's go back to make sure that everybody's comfortable with the sensor. 5-volt pull down design is what we're looking at. Not sure why that just did that. It was in playback mode. 5-volt pull down design, sensor unplugged. I'm going to plug it back in. For those of you following along in my book, this is a good example of why we unplug a sensor like this whenever we do a bypass test. Lost my connection. Oop. For those of you following along, this is plugged back in now. That 0.6 I had is now gone. For those of you following along in my text, this is why when I tell you to do a bypass test, I tell you to unplug the sensor, because if the sensor's shorted out, like this one is, and it's pulling the voltage down already, you're not going to be able to produce a signal. Again, not worried about the ground here. A bad ground would read 5 all the time. But for those of you that want it anyway, I'm going to show it. As difficult as this is to reach, normally I'm looking at my scope at the same time I'm doing this. That should now be connected to my ground. We should see a difference here. I don't think I'm making connection. I'm thinking my actual 5-volt wire. Let me back up here. I'm backing up. I'm really having a hard time doing this. What the heck? Okay, that's the sensor plugged in. Should be the sensor plugged in. And I believe it's now lower voltage than it was before. I could see this at the same time. I'm struggling here. I'd like to see a lot smoother signal than that. So if I shake my leads, I'm just questioning whether or not I'm connected. If I shake my leads, it's staying steady, so that's telling me that I am. Okay. Here's my reference wire. And that should be my reference wire. See that same noise in there? It's a little bit noisy. Oh, I have peak detect turned on. That would be why. For those of you that don't like the noise, and for those of you that have been following my scope stuff, I had my sample rate set too high. That's what all that was. There's my reference. I'll show you the ground too, even though it's not necessary. That should be my ground. 0.01. One more time, go back to the signal. Signal wire plugged in. Sensor is shorted. And I'm going to unplug it again. As long as my back probing tool stays connected. That is now unplugged. See, the second I unplugged that, it went to 5. That is a done deal. Needs a crank sensor. All right, for those of you that feel the need to see that crank count change, we can make it change. And again, what I'm going to do is take my signal wire coming in from my crank sensor, which is this guy unplugged from the scope. I got 5 volts on the sensor side. I'm going to take this with a test light connected to ground. I could use a jumper wire for this, but the reason why I'm not is, well, there's really no particular reason in this case. I could use a jumper wire to ground on this circuit because that's what the sensor does. For you guys that don't like test lights and jumper wires on computer circuits, well, what do you think the sensor does on this circuit? It grounds a 5 volt reference or signal from the computer to ground. That's what it does. I'm simulating that ground. Watch again, crank count. Crank count and RPM. Well, RPM will not change without the cam signal, but you see I'm creating a crank signal. You want to see this move? We need to have a crank signal the same time as a cam, and I'm going to show you that with the car cranking. Even if it does something goofy with timing, I don't care. All right, the count that's on here is being held over. I'm talking to the camera, not you. You're good. I just need you to crank that for me. You need a crank sensor, Pete. The count on here is held from the last one, so keep that in mind. See, I just set it back to, hold on 1 second, Pete. Watch the cam. The cam's gonna be spun by the camshaft itself. Go ahead and crank it. I just made it backfire. Because I'm making it do something that it shouldn't be doing. What? Are you bumping that data link connector, Pete? It just unplugged.
Good.
Is it plugged in down below?
Should.
I lost my data. Let's try that again. I got a no comm. What happened? Did you bump something?
The key was off.
Oh, turn the key back on.
It is. You didn't tell me not to.
Let's try that again. RPM. Wait, crank and cam. Did you guys hear that backfire? That backfire was me really messing up the timing. Go ahead and crank it again. Just want to get a cam count. Go ahead, do it again. Battery's dying. Can't do it. It's time for a new jump pack, Pete.
Yeah, why we never charge it up?
Danny said it was fully charged. I want to try this one more time. Can you crank it for me again?
Did.
I know. I don't know if it's going to let me because of this, but I really want to see this cam count change. That battery's just too dead. It's not letting me do it. Plus, when I'm doing this test, Pete, leave the key on. When I'm doing this test, I'm actually firing the cylinders at the wrong time.
Right, so it needs a good battery to do that.
Yeah, pretty much. Crank sensor, okay? Thanks, Pete.
It's not good to get.
Here, you want to maybe do one last crank for me? Watch my camera, man. Here, look, Pete, you're on. Come on, man. The multiple cameras going. All right. Just because I can't leave you guys with a take my word for it that this cam sensor is fine. And again, I'm basing that off of the scan data not changing. What we want to do is we want to look at, this is now connected to the cam sensor directly. This will be my cam sensor waveform. And my battery's about dead, so go ahead and crank it, Pete. There, good enough. Thank you. That is your cam pulse. So again, let's just make sure you understand why I did that. I did that test because scan data cam count never changed. And what you guys need to be aware of is you need a crank and cam at the same time for that data PID to show up. So a lesson on data PIDs and bypassing signals. Imagine if I was doing a cam bypass test, it wouldn't react to what I was doing until I cranked it. And that was that last video that I did. Again, I'll put a link to this. We are done. Needs a crank sensor, no question about it.